Welcome to the GRIDview Demo. For this demo, we studied an actual distribution system that had 4 substations, 8 feeders, and 1,700 distribution transformers. We had hourly load information for all those distribution transformers, and we used that to run load flow studies for an entire year. We saved all those into a database. We developed a user interface that is a web-based client that can be accessed through any web browser. We're attempting to leverage all this AMI data that's now becoming available at many utilities. Up till now, a lot of that data has been used to send out a monthly bill and not much else. What we're trying to take advantage of is, when you look at it right, that is 15-minute interval demand load information. So we can take that to run these load flow studies. All we have to do is roll that information up to the distribution transformer, and then we have that distribution transformer load which we can use to run these load flows. We're also trying to take advantage of SCADA information, OMS, GIS, customer records, equipment records, weather from the National Weather Service, and of course the AMI MDMS data. When we run these load flow studies, we calculate the loading profiles on sections of feeder. We also have voltages throughout the entire system. We have load flows throughout the entire system, losses, and we present all this back to the user in an intuitive format. So this is GRIDview. We have up here the system load. Right now it's showing 22 megawatts, and right now operators would typically have this available to them in the form of a text-based output on a terminal window. We're displaying this as a bar chart against the daily peak and the system peak to make it more intuitive to understand what's going on in the system. Some of the information that we calculate using GRIDview on all these load flow studies are the losses on the system. So we have the real and reactive power losses, and we're also displaying the power factor. If we click these little binocular button, we can see the history of this data. So by default we're showing 5 days worth of data. You can click on these buttons to get more time, so like you can get a month, or you can create a custom window and use the slider to get different time windows that you're interested in, or there's a year's worth of data, so we can get a whole year's worth of data in one view. The distribution transformers on the utility are typically installed, and then there's very little known about them after that. We don't know how much load is on them at any given time until now. With that AMI data, because we have the customer load information, now we can roll that up to the distribution transformer and know how much load is on any individual transformer. Before this, all we really knew is when the customer called and complained or filed a complaint with the state commission, it's the only way that we knew that there was a problem on a distribution transformer. They might call and say, we have a burning transformer, or there's bubbling goo coming out of my transformer. So now we can proactively investigate overloads on transformers. So let's suppose we click on this bar. This is all 1,700 distribution transformers, and they're broken up in loading ranges. So let's select this 100 to 110% of nameplate, and when we click on that, it populates the transformer list here. So this is coming out of the equipment database. If we select one of these transformers, it will go into the customer database and display the customers associated with that transformer. It will go into the GIS or OMS system and display mapping information, so we'll map that location on the Google Maps, and then we see, of course, the load profile on that transformer. So the utility personnel can use this to figure out, is this overload something that's happening all the time, or is this a temporary thing? Can we use a load factor to create another rating for this transformer? And so these are decisions that each utility would have to make for themselves, but now they have the information to make good decisions on. Another thing that we have here is voltage on transformers. So similar to the loading, but this is the voltage. What we're displaying are voltage violations. Typically the state commissions will regulate a voltage range in which a utility is allowed to serve its customers. If it goes outside of that range, they could be levied fines, they could have difficulty with their rate cases, these sorts of things. But again, the only way that they knew that there was a problem is when the customer called and complained. So much like the loading on the transformers, we're displaying in this case, only the voltage violations. So we click on the bar, it displays those transformers. You click on one of them, grabs the customers, maps it on the Google Maps, and then this is not a load profile but rather a voltage profile. So this can be used to investigate these voltage problems on the system and determine whether something needs to be done about it. One of the most useful features built in here is the section loading. So up until now, the planner or the operator would look at a map and compare the amount of the feeder that he wants to move to another feeder. So let's say that he's a planner and he wants to move a certain amount of load from one feeder to another to relieve it for next year. Maybe he has a forecasted overload, or new business is coming online or something of that nature, and he needs to move that load from one feeder to another. Well, he needs to know how much is on that section of feeder, not the whole feeder, but the section of feeder. So maybe he counts up the kVA on the feeder and uses that to estimate how much he's moving, using the nameplate ratings on all the transformers. Or maybe he uses a load flow program and he runs a load flow scenario to try to figure out how much load he's moving. Well, if he's counting up connected kVA, he really doesn't know how much load is on each of those transformers until now. If he's using the load flow software is typically populated with quarterly peak or annual peak type of loads. And let me show you why that can be a problem. If we go in here, we'll pick a station and a feeder, and I'm going to grab this switch bank here and this fuse bank. Alright, good. And so if we look at the year's worth of data, it's showing a peak load of about 260 amps. Whereas in the last week or so, that section was seeing 140 amps, or maybe even less. So if you're using load flow program and it's telling you 260, or if it's even using quarterly peak loads and it's telling you 220, when really you're at 140, that's a substantial difference. So by having this tool, it gives us better information for planning the system, for operating the system, and this can even be used for maintenance. When there's major maintenance effort or a major construction effort going on, this can be used to have better knowledge of the system when they're trying to reconfigure it for these types of scenarios. So these are the parts that are developed thus far. There are a number of others in development, and